Hello, great mathematicians, and welcome back to our lesson 1 on A-level mathematics, and the topic we are handling is vectors. Without wasting time, let us start off immediately. For a quick review, I told you about what we shall have to have in mind before we can engage ourselves in this topic. I told you the definition of a vector, the IJK notation, the position vector, direction vector, magnitude of a vector, and the dot product. So for today, we are just going to start off immediately with what we have listed there. A straight line can be uniquely determined in space if either we know one point on the straight line and its direction, or we know 2 points on the straight line. If this is the line, I will either know 2 points. This is point A and point B. Or I will know 1 point and the direction. I will know point A and the direction. Someone will tell me it is pointing in this direction. Then I will know, yeah, it is a straight line. But if I just give you 1 point, does it make meaning? No, it doesn't. But so long as I give you the direction and I give you a point, then it is a straight line. A vector, to recap on the definition, is a quantity. All vector quantities can be defined as those quantities with magnitude and direction. It should have size, it should also have direction. So meaning that if you give me point A and B, I can easily tell the direction that I'm moving from point A to point B. That is very easy for me. But if you just give me point A and you don't tell me anything, then it ceases to be a vector. You have to give me either point A and the direction where I should move, or you give me point A and point B, then I can easily know that I can move from A to B. By giving me these 2 points, it implies that you have already given me the direction. I'm also going to hint on the IJK notation. The IJK notation, if this is the XY plane and Z, this one should be at 90 to each other. Okay, it should be 90. If this is the XYZ, remember, if we have XY plane, we have XY, this is the x-axis and this is the y-axis. But in this case, we have XY and Z, the 3 dimensions. This is going to be the x-axis, this is going to be the y-axis, and this is going to be the z-axis. In this case, if I'm writing the coordinates, I'm going to write it in form of x and y. But here, I'm having x, y, and z. I have to write it in the form of x, y, and z. For the xy plane, I denote the directions as I and j, meaning that if I have a point 2 and 3, I will say that it is 2 in the x direction, I will say I, plus 3 in the y direction, I will say j. So this is the ij notation. But if it is xyz, then z stands for k, y is j, and I goes for x. Okay, so if you find a point written in the form of xi plus yj plus zk, then this is the IJK notation I'm talking about. So let us look at the vector equation of a line. The vector equation of a line is given by r is equal to a plus lambda ab, where a is a point on a line, then ab is the directional vector. Now, ab being a directional vector, it can also be written as d. We can give it any letter of your choice, so long as you denote that it is a vector. So it implies that r is going to be a plus lambda g. This is the vector equation of a line, where r is any point on the line. For example, r can be x, y, z. So this is any point, it is varying. X, y, z, it can take on any point. But a can be a point like 1, 2, 3. D can also be a vector. Okay, this is a vector. Then D can also be any vector, which is maybe 2, 4, 5. If I'm to write this one in another way, I can write it as 2i plus 4j plus 5k. Vector notation. This is also a vector. I can also write this one as I plus 2 j plus 3k. It doesn't matter. Okay, I can write it in this form or I can write it in this form. So writing it like this and like this, it is also the same. Writing r in this form and also writing it in this form is also the same thing. Hope that is making sense to all of you. This is the vector equation of a line. Now we are going to look at the Cartesian equation of a straight line. The Cartesian equation of a straight line is given by, this is the Cartesian equation of a straight line where A, B, and C are directional vectors. This equation comes from here. At this point, we shall know how really we come from this equation to this equation, because we are going to meet questions which are telling us to first of all write the vector equation of a straight line. Also, it asks us to write the Cartesian equation of a straight line. So it is not a hard thing, it's not rocket science. Okay, it is easy to analyze. We shall know how do we come from here to here and how do we really form the vector equation of a line. We shall use examples which will guide us very well on that. Now let us start off immediately with the first equation that we formed. R is equal to A plus lambda D. If I have a straight line AB, we are still talking about a straight line. If I have a straight line AB, to move from here to here, I need to have a direction. So the directional vector here, to get the directional vector is going to be AB. If it is moving from this side to this side, then someone will just say it is BA. That is the direction. You start from B, you end at A. Start from A, end at B, it is AB. So that is the direction vector. If I want the direction, I'll say the direction vector is AB. And this directional vector, we are calling it D. Then A is a point on a line. So this point here on a line, remember it has some origin. Vector A, the vector A in this case, okay, is going to be A. Okay, the vector OA is going to give us A. Hope that is clear for all of you guys. And we write the vector equation to get any point here. To get the position at this point, let us call it X, Y, Z. Remember, we are dealing with 3 dimension. If this is X, Y, Z, I'm going to denote it as R. To find the R, I'm going to say R is equal to 1 point on a line, which is A in this case, plus lambda D. This lambda here is going to give us a constant value that if we multiply this constant value by the direction, we shall get the point X, Y, Z. If we multiply this constant value by the direction and add it to this origin, then we shall have that value D. It's like having 2 and I want 5. Then I tell you start from 2 but get for me a 5. So you are going to look at some other value that you will add to a 2 to have a 5. So you will add something like 3. So this 3 here is the whole of this value you are adding. I think it is making some sense. Anyway, you don't need to cram this all. No, you don't need to understand much on this. If you have understood, it is okay. If you have not understood, please just forget everything and just go with the formula that R is equal to A plus lambda D. We shall know how to apply the formula. Let us stop here.